Hello friends, welcome to Dr. Ossai Physiology Academy, DOPA for short. This is a place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. So today, we're going to be doing a brand new topic, osmolarity and hydration dynamics. Always remember that learning how the body functions can teach you a lot about health, life lessons, and even management lessons. So just follow me. Now, osmolarity, like we have said in previous lectures, it has to do with a measure of concentration of body fluids. Remember, we started with lecture 1, the very first lecture about body fluids, the different volumes of the different body fluid compartments: plasma volume, interstitial fluid volume, intracellular volume, and so on. So now we are going to be relating osmolarity, how concentrated the body fluids are. Because when we're talking about concentration of body fluids, the focus is on the ECF, especially plasma, and also interstitial fluid. Okay? That's where we are focusing on. When we say something is hyperosmolar, that means it's more concentrated than normal. Remember that the normal osmolarity of the body fluids, both intracellular and extracellular, because they're supposed to be in equilibrium, is 300 milliosmoles per liter. Okay? So now, how is it related to hydration? Now, hydration is talking about, is a measure of the water content of the body. Now, remember that those body fluid compartments, each of them, they have their normal volume. So if anything happens to the volume, either it's increased beyond normal or decreased below normal, then there is a problem with the hydration. And like I said, the focus is on the ECF. But why we are talking about dynamics is that because of the connection between these body fluid compartments, whatever affects the ECF volume or osmolarity somehow will affect the ICF. In the sense that if there is a change, especially a sudden change in the hydration, there is loss of water. That's the volume, the ECF volume, sudden loss or sudden gain. It's usually, most times, it can affect the osmolarity. And when it affects the osmolarity, there is a problem. It will affect the cell size. If the cell is this size and it loses water, the cell becomes smaller. If it gains water, the cells become bigger. And that process of loss and gain is dependent on the laws of osmosis. We'll just visit it briefly. So hydration has to do with water. The dynamics has to do with the fluid shift in between the ICF compartment and the ECF compartment. So tying these two together, it will help you understand fluid management. Because whenever you go to the hospital, there is something you always notice. A lot of patients, they are connected to an infusion. They call it drip. But that drip contains something. Understand? And what it contains, what you are giving to that person, is based on an understanding of these things. Because there's the most popular infusion you give, we call it normal saline. Okay? Normal saline means that it has an equivalence of the osmolarity of the body fluid. The osmolarity of this normal saline is equivalent to this, so that it doesn't change the osmolarity of it. Okay? So it's a mixture of salt and water. Remember that when we are talking of the concentration of something, we're talking of the amount of solutes. And like we said, sodium ion is the most abundant solute in the extracellular fluid. So it is synonymous to increase in sodium is synonymous to increase in osmolarity. Decrease in sodium concentration is synonymous to decrease in osmolarity. So we are going to be talking about salt as sodium chloride or just sodium, salt and water changes. That's the topic of this. And the things that can cause those changes, the different kinds of changes as it relates to osmolarity and hydration. All right. So let's move ahead. Now let's visit osmosis again so that you get it very clearly. Now, osmosis has to do with movement of water. This is a cell, nucleus. Surrounding it is water, which we said is the interstitial fluid. And the interstitial fluid is also in between it are capillaries that are in constant exchange with the interstitial fluid. Then it enters the bloodstream. So the capillaries are the connection. Okay? So when at each point in time, the concentration of this intracellular fluid, that's the osmolarity of this intracellular, is always or should always be the same. And they are always the same because of osmosis. Osmosis simply means that there is movement of water from where it is higher to where it is lower. A lot of people can easily get confused. Now, wherever water is higher, we are talking about two compartments. This is one compartment. Water is higher here. That means here is more dilute. It is more dilute simply means it has more water content. That's what it means. Any dilute fluid we are looking at means that fluid has more water content. This place is concentrated. That means it has less water content because it has more solute. So more solutes are occupying that space. So it has less water content. So water will move from where it is higher to where it is lower. And it will continue to move across this membrane. This membrane is called semi-permeable. Across. It is called semi-permeable because it allows water to move, but it doesn't allow the solute to move. Okay? Because if the solute can easily move, then it's no longer osmosis. It will just be its diffusion. So the difference between osmosis and diffusion is usually the fact that solutes cannot, the solute there that you are referring to cannot move, but water is the one that will move to meet it and then go towards equilibrium. All right. So that's what happens here. If the intracellular fluid is more concentrated than the interstitial fluid surrounding it, which is part of the extracellular fluid, what do you think will happen? Here is less content. That means water will shift from here to here, will make this cell to swell. When this cell swells, there is a problem. It will destabilize the chemical reactions that are inside the cell because water is the medium for all the different chemicals. And we said that all physiological processes are dependent on chemical reactions, biochemical reactions. Okay? So behind every physiological process, there is a biochemical reaction. Note that. So it destabilizes. Apart from that, the cell membrane, which is very, very important. Everything about the cell is dependent on this cell membrane because that's what it uses to communicate. It wants to excrete waste. It has to pass through cell, and they go through processes. There are a lot of channels in it. There are a lot of receptors, and so many. It's a very complex when you study the cell membrane. So when the cell membrane is stretched, it destabilizes it. So it will affect transport. And once transport is affected, the function of the cell is affected. So that's why we don't want, and the same thing happens when this place is higher, the osmolarity is higher here than inside the cell. Fluid will now move from inside the cell to the outside, and it will shrink. So when it shrinks, the same thing, it will affect the integrity of the cell membrane. All right? So that is why we are studying this, because sudden change in hydration can affect the osmolarity of the extracellular fluid, which will affect the cell, the integrity of the cell, either swell or shrink. So the effect of this fluid shift as it relates to the integrity of the cell membrane, that movement, we usually refer to it as tonicity. Okay, tonicity, the effect of the concentration. So if the concentration is the same, we call it isotonic. So if this one is higher than this within this cell, the extracellular, we call it, we say it's hypertonic. Then lastly, if the osmolarity of the ECF is lower than what is in the ICF, we say that it is hypotonic. So there are three different states that the ECF can be. It will either be isotonic, which is the same, hypertonic, higher, or hypotonic, lower. Okay? So let's keep that at the back of our mind. So we're not going to be relating it with hydration, which means that you can have isotonic overhydration. That's when the fluid compartment is higher than what should, the volume. Remember the plasma is 3 liters, interstitial fluid is what? 11 liters. So when there's sudden increase in the plasma volume from 3 liters to, let's say, 4.5, it will also affect the volume of the interstitial fluid. Okay, so we call that overhydration. Sometimes you can call it hypervolemia. That means increased volume, fluid volume. Okay, so you can have isotonic overhydration or hypervolemia, or hypertonic overhydration, hypotonic overhydration. So when the volume of fluid is lesser than it should be, we call it dehydration or hypovolemia. So you can also have isotonic hypovolemia or isotonic dehydration, hypertonic dehydration, hypotonic dehydration. That means there are 6 different states or possibilities of this connection, this dynamics. So we're going to be looking at those 6 and what could cause it and how it affects the ECF and the ICF. All right? So let's clean this. Let's okay. So This is, let's take this as isotonic. Take this as hypotonic. Let's take this as hypertonic. Okay? So, isotonic, some people refer to it as isoosmolar, hypoosmolar, hyperosmolar, the same thing, right? So, we go ahead and we divide this into two. Okay? So, we'll draw another. Okay? So this is talking about the volume or the hydration. Okay, then this is examples, what could cause them. Okay, then the next thing we'll look at is what is happening to the ECF volume. Then another one, ICF volume. This is, let's start from the beginning. Isotonic dehydration. What do you think happens in isotonic dehydration? It means that you are losing, whenever we're talking about dehydration, loss, hyperhydration, addition. Okay? So, isotonic dehydration means loss. This is loss of isotonic fluid. Okay? So the fluid that is being lost, remember the focus is the ECF. That means the ECF, the plasma especially, is losing fluid. It's coming from the plasma, the extracellular fluid and interstitial fluid. So the kind of loss that will be isotonic is usually hemorrhage. Maybe you have an accident or something. It can even be deliberate. You donate blood. You go to the hospital for blood donation. They collect 1 pint of blood. Okay? That means at that moment, you are dehydrated because you've lost several, about 500 or so mils. So hemorrhage, blood loss, is isotonic because that blood you've lost has equal salt and water. Another thing too, diarrhea, some forms of diarrhea, the fluid that is lost there is isotonic. Okay? So these are the things, most common things that can cause isotonic dehydration. All right. Then now isotonic hyperhydration. All right. Okay. The ECF volume in this one, that means it's decreased. Whenever there's dehydration, there's decreased. ICF volume, what do you think will happen? Nothing. It's normal. Why is it normal? Because the surrounding here and here is the same. So there's no fluid shift. So the volume remains the same. ICF volume. Right? Here is decreased, here is normal. So isotonic hyperhydration. What is happening? There is addition of isotonic fluid. So what do you think can happen? What do you think could be possible causes or examples? Isotonic fluid is being added to the ECF. Okay. One of them is when you drink isotonic fluids, isotonic drinks. Isotonic drinks. Drink a lot of isotonic immediately to increase your volume. That's hyperhydration, but it is isotonic. Another thing too, there's what is called Combs syndrome, which is hyperaldosteronism. Remember that the function of aldosterone is salt and water retention, okay, from the late distal and collecting the late distal tubule and collecting ducts. Okay, so there is hyper, that's more than normal salt and water, sodium with water is being retained, reabsorbed. So it increases the volume, but it's in equal volume. The salt and water that is going together in equal volume. So it's isotonic and it's causing hyperhydration. Okay, another thing too, remember we talked about normal saline. So people that are in the hospital, they go and they put a drip for them. So that normal saline is isotonic. It's usually 0.9%. Usually call it 0.9% normal saline to give you 300 milliosmoles per liter. Okay? So when there's that infusion, it will increase your plasma volume. So normal saline infusion can cause that. So what happens to the ECF volume? It is increased. But because it's isotonic also, there's no shift. So ICF volume is normal. All right? So just note that whenever there's, in all dehydrations, you have reduced blood pressure. Anything that causes hypovolemia, reduced volume of the ECF will cause dehydration. We don't want to write too many other things because they are easier to understand. Okay? There's always decreased blood pressure. Whenever there's hyperhydration, there's always increased blood pressure. Okay? All right. So we've talked about isotonic, which is a little bit easier to, because nothing is changing. All you need is just ECF volume, dehydration reduced. So this is where you need to be a little bit more technical. You need to think and follow it systematically. So we'll continue from hypotonic and hypertonic hydration dynamics after this break. All right, welcome back. So now we want to focus on hypotonic dehydration and hyperhydration. So in this one, there is loss of fluid first because it is dehydration. But what will make the fluid, the ECF, hypotonic means that the ECF has osmolarity that is lesser than the ICF. What will make it lesser? It means that you are losing fluid that is hypertonic. A fluid that is hypertonic means that the fluid that you are losing has more salt than water. You are losing fluid that has more salt than water. So it's taking more salt from the ECF, making it to be hypotonic. So it is loss of hypertonic fluid. But the thing is that loss of hypertonic fluid has more sodium than water. It's not too common. It's rare. It's a bit rare. But one thing, one dicey situation that can cause it is, number one, you lose isotonic fluid like this, blood loss or diarrhea and so on. Then the next thing that now happens is that you now drink water. Okay? Because when you lose a lot of blood, you get thirsty. So you now drink water to replace what you've lost. but then you don't drink enough water. So the water that you drank, the little water that you drank, dilutes your blood. When there's blood loss, it dilutes the blood that is left. So when there is blood loss like this, especially blood loss, it will cause a reduction in the blood volume. But no, the osmolarity remains the same. So you now take water, but you don't take enough water. So the little water you have taken dilutes your blood, but you are still dehydrated. You understand? You are still dehydrated. So it now causes hypotonic. So blood loss plus insufficient intake of water. Some people had Addison's disease as a cause of the Addison's disease. Is talking about when there's a problem with aldosterone. Okay, you don't have enough aldosterone, or your tubules are insensitive to aldosterone, which leads to sodium reabsorption. So a lot of sodium and water is lost. But in some cases, more sodium can be lost than water. It will also cause this. All right. But let's leave that at this is the more straightforward thing. Blood loss plus insufficient intake will cause hypotonic dehydration. So because it is dehydration, ECF goes down. Then it is hypotonic. Okay. I mean, surrounding is less than this. That means this is the direction of fluid shift. So ICF volume will increase. Okay? So that's what happens in that regard. Then the next one, hypotonic hyperhydration. Hyperhydration means there's an addition of fluid. So what kind of fluid will you add to the body that will make it hypotonic? Simple. You are adding hypotonic fluid. Remember, in this one, you are losing hypertonic. Then in this one, you are adding hypotonic fluid. So hypotonic fluid, it could just be water. You just sit down like this and you just start drinking a lot of water. Or you are drinking a lot of alcohol. It will cause hypotonic hyperhydration. So excess water intake. Okay? Or excess water or alcohol. Excess water or alcohol intake will cause hypotonic hyperhydration. There is something else that can cause it. We call it SIADH, syndrome of inappropriate ADH secretion. Now, think back. What does ADH do? Antidiuretic. It prevents water loss. Okay, so ADH facilitates the absorption, the reabsorption of water. So when there is inappropriate ADH secretion, that means excess ADH is being secreted. What do you think will happen? That means excess free water. Water alone, no, it's not adding anything. So excess water is being reabsorbed than normal. Do you understand? So that means it's being reabsorbed, means it's adding to. It will cause it to be hypotonic and hyperhydration. Do you get it? Hypotonic hyperhydration. So what happens here? ECF volume is increased. Hyperhydration. Then what happens to the ICF? Since it is hypotonic, it will be increased. All right. So now let's move to hypertonic dehydration. In this place, you are losing what kind of fluid to make it hypertonic? You are losing hypotonic fluid. Remember, if you are losing isotonic, it will remain the same. If you are losing hypertonic, it will make it hypotonic. So here you are losing more water than sodium. I mean, there's now excess of sodium being retained in the ECF to make it hypertonic. Are you getting the logic? So there's loss of hypotonic fluid. Loss of hypotonic fluid. So what do you think what kind of situation do you think there can be loss of hypotonic fluid? A very common one is excessive sweating. Sweat contains more water than salt. You know, sweat is salty. When you are sweating, there's sodium chloride and water and some other things are removed. But there is more water. When you are sweating so much, you are losing more water than salt. So it's making it hypertonic and you will be dehydrated because of the loss of water. Okay? So excessive sweating can cause that loss of hypotonic fluid. Right? So what other thing, apart from excessive sweating? Remember, you are losing hypotonic fluid. Fluid that has more water than sodium. There's something called diabetes insipidus. Diabetes insipidus. What does it mean? Diabetes insipidus means that it's opposite of this. You see it, it's opposite of this. Now, this one, ADH is being secreted, so water is being added. But in this other one, there is lack of ADH secretion. You understand? So if there's no ADH, that means water is not reabsorbed in the tubules, the late distal tubule and so on. So what happens? That means you are losing a lot of water. You will be urinating and excreting very dilute urine. It could be so bad that in a day, you can lose up to 20 liters. You can urinate up to 20 liters of urine. Very dilute urine. So this, you can have central diabetes insipidus. You can also have the nephrogenic. So what does central diabetes insipidus mean? It means that the problem is from the brain. Remember that ADH, first of all, is secreted from the hypothalamus, then stored in the posterior pituitary. These organs, they are parts of the brain. Okay, that's why it's called central. Anything about the brain, okay, and spinal cord are referred to as central. So the problem is from there. It's not secreting ADH. There's a problem there. So when ADH is not secreted, water cannot be reabsorbed. You'll be excreting a lot of water. Okay? So when you're excreting a lot of water, in excreting excess water that is very dilute, what will happen is that it will make your extracellular fluid hypertonic because just only water is being excreted. So there will be dehydration and a lot of sodium chloride will be left, making it hypertonic. So excessive sweating and diabetes insipidus, loss of hypotonic fluid. So this nephrogenic is just talking about the fact that, nephron, that means the problem is in the kidney. The the pituitary gland secretes the ADH. Okay? But the kidneys are not sensitive to it. It's just like it's not being secreted. Although it's being secreted, but it's like it's not secreted. They're insensitive to it. So they cannot respond to the ADH. So the same thing also happens. Water cannot be reabsorbed. A lot of water is lost. So central, nephrogenic. So these are the two major things. So now you have dehydration, which means ECF volume is decreased. Now you have hypertonic, means the surrounding fluid is higher than what is inside here. That means here that is lower, water will move from here to here, which will decrease this volume. So there's decrease in ICF volume. So that's that. Let's go to the next one, the final one, hypertonic hyperhydration. It means that there's addition of hypertonic fluid. That's what will cause hypertonic hyperhydration. Okay? So what that means, you are taking hypertonic drinks that are very concentrated, hypertonic drinks, intake of hypertonic drinks, and also intake of seawater, very salty water, seawater, hypertonic drink will cause hypertonic hyperhydration. Okay? Since it is hyperhydration, ECF volume is up. Since it is hypertonic, the surrounding is higher. That means fluid is moving here. This will shrink. So ICF volume decreases. So this is what happens. Okay? The different osmolarity and hydration dynamics and the different possible causes. So when you see that somebody is dehydrated, it's not just enough to say the person is dehydrated. That dehydration, is it causing hypertonicity? Or the person, the dehydration is isotonic, that, the blood is isotonic. There's no change in the osmolarity of the blood. So that can give you an idea. And note that even in this blood loss, when you lose blood, immediately it is isotonic dehydration. But over time, when you now drink water, which we said can happen here, you now drink water, it will now make it hypotonic. So whenever there is blood loss, you can tilt. So you know what to do in such situations. You have hypotonicity. That means you need to add hypertonic. But when somebody is already hypotonic and you are adding more hypotonic fluid, giving the person drink that is more hypotonic, that person can die. You understand? When there is a lot, you know that there's what they call water toxicity. Remember that in this one, hypotonic hyperhydration, say excess water intake, alcohol water intake. When you take so much water, like you carry 5 liters of water now and just drink within 10 minutes, you know that you can die from that. It's called water toxicity. As you drink the water, it will so much dilute your blood that what do you think will happen? It will lead to shift from the ECF down to ICF because the ICF is now more concentrated. So because of the so much dilution, so much water enters your cells will swell and burst. And especially the brain cells, there's so much hypotonicity. So they swell and it's called cerebral edema. You go unconscious and you die. It's called water toxicity. So these are the things that you need to know at this level. This osmolarity and hydration dynamics. So for further reading, I've written a book on renal physiology. You can check it out in the description box. You see the links there to download a soft copy of the cannabis for just a little token, okay, to get a better grasp of these things. Also, you see our website, the link to our website. Go check out our website. So many other amazing resources and services that we offer that can help you to do well in your learning and understanding of physiology. All right. So see you in the next video.